So my talk is Debugging js-ipfs like a pro. That was the title of the talk. I added like a pro wrestler. This made a lot of sense to me at like 2 a.m. when I was writing these slides. Yeah, I'm not sure how far I can stretch this analogy, but we'll see. Because so I mean, obviously there's like the grappling aspect. It's hard. There's no guarantee of success. Also, like, so I grew up in the UK, like in the 90s. There was only terrestrial TV at the time, and then this thing came along called Sky TV, which is like it's television through your satellite. Amazing. It's like living in the future. And one of the things that was on Sky TV was WWF wrestling. And yeah, like as like 10 or 12-year-old me, I'm not quite sure on the actual time scale, that it just seemed impossibly exotic. And now I lose so much time reading biographies and the stories of what happened to all these people on Wikipedia. But all the actual wrestling shows, it always strikes me that it's more like a soap opera than actual sport. I mean, obviously it's sport. There's incredible physiques and all that kind of stuff. But the actual things that are happening is like a soap opera. And like any soap opera, there's only, what was it? There's a famous stat. There's like 6 or 8 plots to any soap opera. And they just get repeated endlessly. And then and when you're debugging things, usually there's a few things that are always bad, like string concatenation, regular expressions, like memory copying, that kind of stuff. So usually you can find, like, you're like, this was probably it. But also the one thing about debugging that doesn't apply to soap operas is like measurement is super important. It's really easy to go down rabbit holes chasing the wrong thing, so you must measure everything. Measure absolutely everything. Yes. So who am I? I'm Alex Potsides, Aching Brain on the internet. I'm on the IP stewards team for Protocol Labs. I maintain js-ipfs, js-libp2p, a lot of the JS stack. I am hiring. I would like to not maintain all these things all the time. I would desperately like some help. So please come and talk to me if you'd like to join the team. So we're going to cover some things. Logging, debugger, metrics. Going to go back to logging briefly, and then like Prometheus to actually get some stats out, and then hopefully we're going to fix a problem, assuming I can replicate it. So logging. This is, so we have a lot of logging in js-ipfs. It's all based on this libp2p logger package, which really is just using the debug module. It's behind this extra package because debug is not ESM yet. So at some point we can switch it out without having to change all the code everywhere to use an ESM module to get proper support for SkyPack and all these like future tech things. So it's a very simple API. You just have the name of the module, the name of the subsystem, and you have three ways of calling it. You get the regular log, you get a trace log, and you get an error log. And we'll see how we can pull these out individually later. To enable the logging, it's very easy. There's just an environmental variable, debug, and you pass in a pattern. This also works in browsers. You just set the local storage variable. With the caveat that, with the Node version, if you Control-C and then you start again with just js-ipfs, you won't see all the logging. In the browser, you definitely will. So if you set it to be something that's too verbose and your browser catches fire, it will catch fire as soon as you restart the page, reload the page, sorry. So be careful. And you have lots of options. So you can have wildcards. The second one will give you everything. It's very noisy. And then you can have multiples, and you can remove things. You can do individual things. It's going to start up. It's like, great, now what? It's a completely black box. I have no idea what's happening. So I can stop it. Start again, debug everything, all the things. Yeah, it's like it's too much. Definitely too much. So we can stop and we can have a look at what's going on in here. So we can see we've got like the peer store. It's doing things. MDNS is doing things. More MDNS things, more peer store. You can see that some of these components are very noisy. Mplex, incredibly noisy. So Mplex is like printing out the different messages that are coming in. These are very, very noisy. So let's just look at like one thing. So if we just look at identify, for example, we can just start it up again, and now we'll only see messages from identify. Which is probably, an interesting thing to choose, given that I need some network connectivity in order to actually run identify, and obviously this is conference Wi-Fi, so, dead air. Anyway, you have to take my word for that one. Okay, anyway. So, too many times. Anyway, I'm going to move on. So so you can have multiples, you can have individual components. This is my favorite one, is just to basically remove multi-stream select and then remove all the trace logging because it's very, very, very noisy. It would be nicer to have a way that doesn't turn on trace logging by default, but that's the Debug API. So yeah, a more concrete example, here you go, starting up, showing all the things. Okay, that's logging. What else? So this is more like general how to debug node things. This is the debugger. You can obviously do this in the browser too. In the browser, it's super easy. You just pop open the developer console, stick a breakpoint in, and you're away. You have to debug it all the time. In Node, you don't. So you've got the inspect command that you can start the node with, which will create a port, and you can connect to it using the debugger that's in every version of Chrome. So if I start node options, inspect js-ipfs daemon. So now I see a message, the debugger is listening. So now I can open in Chrome, make in begin. That's useless. I want to show the URL. So the URL here, you're going to have to take my word for it. It's way too far away for you all to read it. But it's the chrome://inspect. And then you'll see that we have a remote target that we can debug. So I can connect to it like this. In the console, I see debugger attached, and suddenly, here I am. So I can now debug things, which is fantastic. So I can stick breakpoints in here. Obviously, there's a lot of code, and we can inspect what's going on. That's very useful. What if I forgot to start it? Wait, hang on. I'm back. So that's useful in that the js-ipfs is started up now, but what if you wanted to start from the beginning of the process? So you want to put breakpoints in, maybe you're debugging the startup process. You obviously can't connect to it quickly enough, so you can use the inspect break, waiting for debugger to disconnect. Okay, disconnect. So the other one that you can use is inspect break. So now it's attached to the debugger, it's paused the process. So I can go back to Chrome, the target is turned up, and I can log on to the debugger, and now it has stopped before the very, very first import. So now everything's suspended. I can go through the source tree, I can stick things in and debug where I want to. Obviously, because, actually no, that's fine. If you're debugging libp2p like this, because it's all now TypeScript, you need to go and put the breakpoints in the compiled JavaScript rather than the TypeScript. I'm sure there's a way around it. Source maps, they just never seem to work very well. Anyway, so I can go into the core somewhere, maybe the startup. This is the dist. So js-ipfs is all ESM and not TypeScript. So I can go into the source components. I don't know, index, and just stick a breakpoint in our constructor for IPFS, and then just click play, and it will, there we go. So now it's paused a part of JS startup. So I can look at the scope, I can see how the variables are going to be defined, I can see all kinds of things. This is very useful, I can step over things. This is a debugger. Debuggers are wonderful. It's like the Swiss Army knife of tools. I don't know what the wrestling analogy would be for this. I don't think there is one. So I told you I was going to try and stretch that analogy as far as possible. Anyway. Okay, so that's the debugger. So what if you've got a running process and you want to debug it, but you didn't specify those arguments. No problem. You send the SIG-user1 signal to the PID of js-ipfs. And we can do exactly the same thing. So if I just let that one go, disconnect the debugger and kill it, and I'm going to take 2 of these, big and big. And so here I'm going to do js-ipfs daemon, run. Hooray. And then in this window, I'm just going to do a bit of js-ipfs. Oh, sorry, I'm going to do a bit of ipfs. Because it renames the process, you'll notice, to ipfs and not js-ipfs, because why not? So we have the PID there, so I can just do kill. Obviously, don't forget the dash. If you just do sig user1, and that will actually just kill the process entirely. No, not what we want. So there we go. So now the debugger's listening. It's appeared in the inspector again, and I can open the debugger, and we're away. Very useful. The debugger. Metrics. So this is great, but what if, I mean, we want to be able to see things like CPU usage, memory usage. There's a whole bunch of interesting metrics that ipfs exposes and libp2p, but only if you set this ipfs monitoring environmental variable, because the metrics are not free. Saying this variable will configure a metrics object within libp2p itself that is then shared by ipfs to add extra stats around like bit swap and all kinds of stuff. But you must specify the environmental variable ipfs monitoring true. Something else this does is it creates so the way Prometheus pulls the stats out is that it will create an endpoint that the client can call. It also enables another endpoint that lets you dynamically change the debug level for the debug login, which is incredibly useful. So if I start, disconnect the debugger, kill the thing, ipfs monitoring true, there's ipfs daemon. Okay. Let's go back to that. What was it doing next? Yeah, logging. Okay, fine. So here we go. So starting up, we've got the monitoring, and then if where's my thing gone? There it is. So we can now that this is running, there's an extra endpoint that's running. You can, if you're hardcore, use curl or wget or whatever to then send a request. It's a post request, the magic URL, debug, but you have to escape all the colons and that kind of thing. I don't hate myself, so I'm not going to do that. I'm going to use an app to do it. So I'm just using this REST client. Can I make it bigger? Yeah. This is just a simple client called Insomnia that I use to make requests, because I can just type the argument in. No, it does it for me. So I just type this bit here. The question was, do I still have to URL encode if I'm using this app? No, I don't. It does it for me, so it generates the URL that it's going to send it to. So you could then actually take this and paste it into the terminal if you wanted. But yeah, so you can just type the thing. So if I send the request, and then suddenly my console's gone mad, and suddenly now the log level has changed, which is useful. So if I change it to go back to doing a single component, so TCP, start, send. Now I'm only going to see TCP messages. This is also interesting because we see lots of read timeouts where we're trying to connect to remote nodes and they don't respond for whatever reason. Okay, so what else? So we have exposed a Prometheus endpoint. Prometheus is fantastic. It lets you get nice graphs. It also means that we can now do nice things in Grafana, like all these wonderful dashboards that everyone sees. You can use them with js-ipfs. There's loads of fun metrics in there. So Prometheus, yeah, I'm not going to go into too much detail about Prometheus. You can go to the website, download it. It's super easy. You just configure a job with this. You just ensure that your config file has scrape configs with the metrics path and the host and the port number, and then you just start Prometheus with the config file. which is great. And it looks a bit like this. Where has it gone? Yeah. Can't update. No, don't reinstall Chrome. What? Not now. Where did I put it? Yeah, so there we go. So this is Prometheus. Obviously, doesn't like being zoomed in very much. So we have lots of useful queries in here. So for example, here we just have like all the memory usage by node. Gives us a nice graph. I'm going to change it to just be very short. So we have our node startup, spikes the memory, goes back down to something reasonable. The green thing is the interesting one. It's the amount of heap size that we're using. So above that, there's the total heap, and then the total memory usage of Node.js. So obviously the operating system is going to vary this. We can only really affect this one, which is the amount of heap used, which is like, just under 200 megabytes, which is not too bad for a JavaScript application. So there's some interesting queries you can run. So like, there's no nice and easy way of pulling CPU usage out of Prometheus, but you just use this fantastic little function to do it. You see the memory usage. So the node memory usage is actually a custom one that's added by js-ipfs that just like takes all the node stats together and puts them on one graph. It's quite useful, I find. And we have some specific libp2p ones. So the number of connections. You can instate the spectre bit swap, and we're adding more. So one thing that's happening, like specifically with ChainSafe and Lodestar, is they're very, very interested in the performance of like the TCP transport. So there's a whole bunch of stats being added around that. Also gossip sub, like the state of the mesh, the number of retries, like the scores of various peers, loads of metrics around that. They've actually implemented their own metrics gathering because the default libp2p one was lagging a little bit and they needed it like yesterday. But it's very much on the roadmap to try and bring all those together so that you can get really good stats out of all the very high like contention resources within your IPFS node. Yeah, so we can see in here we have, you can just type libp2p and you've got all kinds of interesting things. So you've got the DHT routing table sizes, you've got some MPLEX stats, the number of listeners that we have for transports. Other interesting ones are like the active handles. So this is the number of, essentially the number of sockets that you're holding open. So you would expect this to track the number of active connections that you have. If the handles go way above the number of connections or they keep growing, then you've got a leak somewhere and you need to find it. Which is like, yeah, more typical than your average memory leak. So this is the number of connections we have. Obviously, we're in a conference zone, so we're going to see some interesting things. So I haven't actually connected to anyone, but I have 63 outbound connections. So I'm dialing peers that I'm ambiently discovering. Yeah, Prometheus is very useful, gives you a great window into what's going on. Right, so it's been very dry so far, but we're going to try and do something interesting now. So we're going to put it all together. So something that I'm quite interested in is that little spike at the beginning. We saw it in the memory. So at the beginning of your startup, so here's like the CPU. So this one's interesting. So there's this spike that goes down, and then we do nothing for a bit, and then we go back up. Something worth investigating. But I'm quite interested in this little spike here that when we start up. So obviously, when you start a node up, it's doing nothing, then it's doing something. So you're going to start. The CPU is going to spike because you weren't doing anything, and now suddenly you're doing something. But let's see what's it actually doing. So if I kill my node, and I'm going to start it in debug mode and take a CPU profile. Kill all the things. I kill it with force. Still running. For the interest of, okay, it's done it. Great, cool. So I'm going to do monitoring true. I'm going to do node options, inspect, Berg, connect to the debugger. start the profiler, start taking a CPU profile, go back to the sources. Does this stuff ever work? It has started for me. That's great. That's interesting. So I've connected it. Oh, yeah, so I've connected a CPU profile, and that has started it for me, which is good. The daemon is ready. So now we're going to look at the CPU profile. Is it very small? It's very small. So in the CPU profile, we have two measurements, self-time and total time. So this is the amount of time that we spend in all these functions. Self-time is the amount of time taken for a function to execute, but minus the time when you call out to other functions. So if you have one function that you think is very slow because it's doing something like looping over a bunch of arrays or something like that, it's going to slow down in self-time. Total time is sometimes more useful because you can see how, like, you can kind of descend into the stack and you can see where the CPU time is taken up, and you get more of an idea of where, like, the components that are the bad ones and that have the dependencies that are slow. Because often the code that is slow is not your code. It's often other code that you're calling. So if we go, so we can look at, we've sorted it by the time taken. I can look at the callback trampoline on message. So this is interesting. So here we go. So it's a datagram. So this is not TCP. This is going to be UDP, something that's happening. So already, so we start thinking, like, what do we use for UDP? So there's no Quicken node yet. But we do other things in the UDP. So some of the things that we do is like MDNS is all UDP. Events. Oh, look, there's MDNS. That's interesting. So what's going on here? So we're making MDNS. So what do you use MDNS for? So we use it for local discovery on the network. So we're obviously in this zone. I mean, how many laptops are there in here? I can see at least like 7 or 8, no, 10, 15, and then imagine all the other people around. There's a lot of laptops. There's going to be a lot of MDNS going on. So we can go further in, get addresses, encapsulate. So we can obviously click through and see what's happening. So if I look at this, where am I? I'm in multi-adder. Oh, that's interesting. So I can dig down further. Obviously, the percentages are getting smaller and smaller. We can go down string to bytes. Hello. So we're doing something with a string. Like, what do we do with strings? We have to parse them. What do we use to parse strings? Oh, no. Convert to bytes. IP to bytes. To bytes. Is IP4? Uh-oh. Match. What do we match on? Oh, no. Is it regular expressions? Have we got a really slow regular expression in here somewhere? I think we might do. So... I think it's so you don't dial rubbish, like a string that isn't a regular expression. So anyway, so now where are we? We're in this is match. And here we are. Oh, look, it's a regex. Oh, cool. So what we found is we've drilled all the way down. We found that there's a slow regular expression somewhere in our stack that's around multi-adders and like parsing multi-adders from strings. And yeah, so if we actually look at, can I get a window? This is an interesting thing, because it actually came up in multi-formats, multi-adder. Oh no, why am I doing this on conference Wi-Fi? Oh no. Anyway, this came up recently because Lodestar actually noticed that there, and I say recently, I mean like yesterday, because Lodestar actually noticed that, I'm going to switch onto my phone. Yeah, Lodestar noticed that they were consuming an awful lot of CPU usage, bugs, pull requests. So they found that we're using an awful lot of CPU usage in this, in Lodestar. So they did very similar investigation, and so they found actually in this is-IP, you can see it, it's actually using 9.75% of CPU time, because they obviously have very high traffic nodes, and so there's a lot of parsing of this stuff. So that is a terrible, terrible stat. And what they've done is they've taken, so they've measured it and they've identified the bottleneck. And what they've done is they've actually taken all the regular expressions out. They've written a new regular expression, a new IP address parser that's actually based on the Rust implementation. And it's between 30 and 300 times faster than is-IP, which is great. And here's a PR from them, very helpful, which swaps it out in multi-adder, which is going to solve our performance problem. This is the power of open source. So I'm just going to merge that one. Yeah. And yeah. Thanks. That's it. There we go. So we fixed our performance problem. Someone else fixed it, which is like, it's the key to successful software development, is making your problem someone else's problem. And they've done it, which is great. That's it. That's the talk. Thank you very much for attending.